Hello everyone, I'm Xiaogan. Let's start writing. Actually, just talking about this agent is a bit boring. In fact, a lot of this content doesn't really need to be memorized. You just need to know how to use it when the time comes. But we still need to cover it. Actually, if you look now, many Apple users have already pasted the relevant business code, telling you how to bind and use it. So let's still write it here. Let's try to go through it once, because it's used so frequently. Actually, this kind of knowledge is just like strings. Functions, blocks, and pyropia. They are all very common types of knowledge. They are used too often, and we often create 4 classes, respectively, representing our single wave. Well, obviously, this is a normal multi-wave. Then, obviously, this is a dynamic multi-wave. And this is our dynamic single wave. Then let's start writing the simplest one. We'll demonstrate them one by one. Okay, now we declare. First declare the simplest one. Our delegate will be called is the server. And this method, actually, if you type it normally, there will be hints. Yes, key. It will be here. This wasn't available in previous versions, but it seems that after the update, it actually appeared. You can see. They are all here. We'll just paste it over. Now, we declare here. We still start with F. Yes, we must start with F. We call it XG, single delegate, and it no longer has a return value. Okay, so for this delegate, what function do we want it to perform? We give it a function like this, called printLocation. That is, any. This gets the position of an object in the scene. It will execute and print its current position. So obviously, after we have such a delegate. So we might need to declare it. This means we need to instantiate it. Right now, it's only defined. It's only defined to be like this, but we haven't actually instantiated. This way, it's instantiated. Once we have such a proxy, let's see. Now the compilation can pass. Here, let's try this. Paste it. Displays reports an error. It's a test code I wrote earlier, not cleaned up properly. Now the compilation doesn't report errors either. It should be fine without a semicolon here. Let's take a look. As an aside, let's add a semicolon to separate them. Sometimes the semicolon is used. Sometimes it's not. It doesn't have a big impact really. It depends on the situation. That's all. Then, with such a delegate in place, remember our rule. Before the comma, after the period. Then this delegate can be bound to any object. Right? So I'll start with a conventional approach. Here, let's declare another actor. Okay, let's declare another actor. Alright, this actor we'll call XG location. We call it location actor. Then we have a constructor here. We don't need things like these. We only need a begin play. And avoid this to avoid us. Other things, actually, we don't need the constructor either. Let's just remove the constructor directly, but the constructor is still needed. We still need a constructor, because without a node, it doesn't seem very convenient. Then let's paste it up here. Let me first show you a standard approach. Let's demonstrate another approach like this. Okay, so here we just need to trigger his root combo again. It should be create default. For sub-object, we give it a useThing combo. This is it. Then we need to pass a name for this. Let's call this image's name. Location, root. Okay. With that done, what do we do next? Then, before saving, we need to bind this properly. If it's a single wave, then here. Binding it this way, actually. The binding here is a bit troublesome. We should call it stupu game play hismet. Let me check. It's not easy to find because this thing is static. We need to find it this way. It's vector. Actor of should be the function we are looking for. That is, it found it. You can see the function we need to use is this one. At this point, we need to include its header file. Obviously, the location of this header file should be here. It is under Kismet. Have we used it before? It seems we haven't used this function yet, not used in the world context. I will demonstrate it to you right now. It is under Kismet. Okay, so here let's look at what parameters it has. Obviously, it needs to pass a world context. We'll just pass that. At the same time, we can pass in its static class here. Then we will, in the scene, retrieve such an object. Note that it only returns one object. We'll give it this name of ours. The return value we get is an actor. We might need to cast it. Okay, then we call it Delegates. We call it a single delegate pointer. Actually, if you're used to it, you can type it like this, telling yourself it's a pointer. And if it succeeds, then if this pointer exists, we actually need to cast it again like this, like this. Then here we type action trig. We have a case here. We use this cast. There is a cast check here. The difference between the two is whether it will trigger an assertion. That is, it needs to be checked. Yes. The type we convert it to is this. At this point, we put this pointer in. Okay, you see, if the conversion here is successful, we prove that we can find this object. Then, for our convenience, we set this place to public. After finding this public one, we make a binding here. Bound. Obviously, here, we first need to find this. Then we click on bounds here. If we bind it this way, we display it in this manner. BindUObject. Okay, so obviously we need to bind which object, right? Then we need to specify this method. As for this method, we know it has no return value and no parameters. We can place it a bit higher. Let's try to place it higher, because if you don't place it higher, it might not find this thing and will report an error. Okay, then after we place it here, we need to write a method. We'll call this method void print location. Okay, then the operation this method needs to perform is very simple. We'll just use from Gregstargarically vector. F vector should be the applicator. Then here we have my location. We'll just let it copy. We need to get actor location. We can get its current position. Okay, let's make a copy of it. Then we'll print it directly here. It might be a bit troublesome. You might think this thing, why write so much? This is just the first example, right? We'll just explain this thing to everyone, how it is used. Here we give it a is key. Okay. Then we just give it a %s. We can do it this way. We can write it like this. Then my location then give it another %. Our first %, it is quite obvious. We want to get the position where this function is executed. Then we can write it like this. Okay, then for the second function, we look at this to actual. Let me see if we can directly to string. We can directly to stream. We just convert it to stream. Then we convert it to a new one. Note that it must be converted to a new one. Okay, so the execution effect of this function is that it will execute at this position. Okay, it's that simple. Okay, so obviously it's just we have bound it here. That is to say, our location actor, will report to our UGameplayStatics. That is to say, I have registered my task on your delegate. Then when you need it, we can execute it at any time. Then the registration is completed during begin play. Then at this point, it's bound. We need to write a method here. So we write a method here called write it here. We call it call location actor print. Then for this method, we need to debug it, right? We can do it like this. Salute cable. Then give it a cutter graph. Okay. So here, if we let it do it, it will be fine. It can be simple. We can just let it execute right here. So this is the execute, right? Actually, you can write it like this. There's nothing wrong with writing it this way. Write it like this. That is to say, then let's first check whether it is already bound. If it is already bound, then we execute. If it is equivalent to if you execute it once, then you can also clear it here, meaning I only execute it once. Take a look for unbound. Yes, because in this place, it's equivalent to executing only once. Then it won't execute anymore. Of course, we can make it execute continuously. That doesn't matter either. Okay, we can also just do it like this. We wanted to keep executing this function, so we can do a ExecuteIfBound. Then now it should be like this. Such a situation, you can say this unbound one is to unbind this bound delegate. Good. Okay, now let's do a simple test to see if it can meet our requirement. So now our delegate, it gets the position of the location actor in the scene. So this location actor can refer to an NPC, can refer to a monster, can refer to the position of a treasure chest. That is, I don't know. I don't know if this object exists in your scene. I also don't know what this scene object specifically is, but I know that if I execute this method, then in my scene it will inevitably let it in my scene it will eat 一方撇. If there is one, it will take effect. Then if we need it here, we put this location. Drop it here by code. Here we put it in front. Then we put this. Single delegate actor is all here. But it doesn't have trace force, so it can move. We don't need to worry about it. Then we need to make it execute. So in the level blueprint, we do it this way to facilitate our testing. We use a key test. When we press this key, we get its reference. Then we import xt here. We can find the collocation point. Okay, let's check our log to see if it prints normally. You can see it printed twice. This means the scene is at this position C311780,080. You can see 3107 T08. Now we remove this scene. This object, actually, there won't be any problem. It is simply not bound. It will not execute. So this is a very simple, such a single wave delegate because it is very common in our application scenarios. Very convenient. Next, we will give you a simple OK for convenience. We give it a parameter. Give it a return value. So we don't have to make it too long. In fact, regarding this declaration, let's take a look at this declaration method. We first need another parameter, right? Then there must be a 1 here. Let's take a look. When we declare a parameter, it should have a suffix. It should be this one. And because it has a return value. So when we declare it, we need to add this return value. So it should be like this. That's how it is. So we need to, at this point, we hope that when we execute, we save this position. That's also very easy to do. Does it have a return value? We need to set up the return value first. We consider the return value to be a vector. Okay, let's make it copy here. Because this part is single. No, it's not dynamic. So we don't need to write a name. We can just write the type. Then this, let's call it saved. Let's not call it print. Let's call it get location. That is, we need to get this location and we need to pass a parameter. We use an fstream. Okay, then we created a new agent. It is called this name. Similarly, we also instantiate it simply here. After instantiation, we call it this name. Okay, then we still go here. And here it has a return value. A return value needs to be given here. For EXECTR, BindUObject, then called getLocation. Then it will pass an fstring as a parameter. Here it is called instr. Now let's create an implementation of it. So we also need to do a binding. We'll still bind it to the same object. This way it's a bit easier for us. Then put it here. Here and then. Now notice that you see a red line here. It's because the function line doesn't match. Okay, so that should be fine. Writing it this way is fine. Let's continue thinking about it. Then let's still have it do this. Let's still have it print something. Except here. We'll do it here. We return this value. Okay, so when executing it, there will be a return value. Then we won't use this here. We'll write another one. We call it collocation actor. Get okay. So the name is fine. So what does it do when it executes? Actually, it's the same if these are bound properly. We just let it execute and it can receive. It should be able to receive. Because yes, we call it my reserve. Location is where I receive this location. You can take a look. We might need to do this. Let's see what this value should be. In what way to receive it? It should be like this. Take a look. Okay, you can look at it. And here you need to pass in a parameter, right? You can see, we can zoom in a bit. You can see here. You see, this part is actually a boolean, right? And here it is, a return type. Obviously, it is a genetic one, and it is variable and can be loaded. We will demonstrate what loading means later. So for this execution, we will pass it a string called my single elegant. That is who issued this command, right? So obviously here, I will give it another function method. I don't need it. I no longer need the function method. I'll have it put this in. And then who issued this command will be printed by it. So here we have contacted him. We can then set and modify it. We can only do it here. We can only print it. You can save it just now. Right, there is no problem with this. That is, once you get this position, health or money, you perform your corresponding operations. This is completely fine. Save it here. So here, we will just use this to do it. Or we can just write it like this. We will just write it here. Here's the Meyer save. Okay. Now let's execute this method. Execute the single band lading method. Okay, then let's check our map. there is only this one object in our scene. That definitely won't work. Let's put this locate actionator here. After putting it in, we are still at this place. Let's have it test with cable 2. And the test result is called, we'll just type XGA called gate. Actually, I am here. You can get a return value. Now let's execute it. Okay. Take a look at this place. Save it. We haven't pressed 2 yet. You see our first printed log was printed in this location actor, and the second printed log was printed in our own actor. This is a very good interaction process. So we can set a breakpoint. Let's set a breakpoint. We won't look at the binding. Let's set a breakpoint right here. Okay, actually, let's set another breakpoint here. Then let's take a look at the call stack. Okay, after we enter, pay attention to our call stack. Let's continue stepping down. It will go here. You will notice it needs to go down. This place is right. So when it executes this part, it actually enters here. You can see our stack right here. These in the middle are some blueprint functions. This thing standing here because we bound a UObject, right? You can see we keep it as UObject. It doesn't actually mark U function here, but that's fine because we are using UObject. Looking it up through it, when our object is destroyed, it actually won't be a problem here. It won't have any issues. We just tested it and there were no problems. Then actually we can look at the delegate keep awake reference. Okay, this wake is very important. When we talk about smart pointers, we mentioned weak references. That is, it won't affect your lifecycle, but when your object is destroyed, it will receive a notification. So obviously there is no problem here at all. Okay, so one application scenario of single cast is like this. Now let's supplement for the payload. This payload is very useful. It is the essence of single cast. So we still declare such a stream, but we declare a new method for it. We call it, let's take a look. How should I demonstrate this code to you? Okay, let's still use this delegate for the demonstration. But the main change is here. Then we might need to instantiate another one. So when we instantiate it, we need to express this again. We call it waste cannot. The concept of overloading is very important. They are in its playout. When we bind here, we need to make some changes. We still use it for binding. Okay, there's no problem now. Here, we need to do it like this. Like this, okay. Good. So doing it this way is completely fine. Actually, this delegate, you can declare it anywhere. You can adapt it to an object or pointer, or whatever, as long as you can find this place. And then let it call this bound thing. And this part is still exactly the same as before. But we need to slightly change this getActorLocation. We need to change it. So when we call getActorLocation, we give it another parameter. Let's call it an int32 parameter. For int32. Let's give it one called health. Our int2 is also called money. Okay. Then here, we don't want. We hope to avoid overloading it as much as possible. To prevent it from happening, because we know UObject actually doesn't support overloading, let's try to keep them more distinct. If you're interested, you can try it out later. And this function will bind it here. But here's the interesting part. So here, because its function signature is like this, so what it means is that this function executes with these two parameters. So if we do a binding here, we can declare a instance2 current else equals 1000 instance2 current money equals equals 18. And here we need to remove the space because it cannot be like this. cannot be used in our variable name declaration here. This is called the composite way of thinking. This way of thinking is that at the moment we bind, it will pass this value in. So in reality, if you make a very simple modification here, we give it a supplement. We give it a equals 5. Okay, then actually we can receive this parameter here. Similarly, here, keep it simple. Then we print the intern and money counts. We give it a health. Then just give a %d. You might be a bit confused when you see this part, but this is to let you have such a contextual interaction. We give it a... We'll just put this chaos here directly. Okay. When it executes like this, it will take this. There is an error here. Let's look at the reason for the error. There is an error in this place. Then we compile, no errors. It didn't recognize it. So when we bind like this, it does not capture these two characters. Bind them as a copy by value. These two characters will not generate these two characters. These two characters always capture a copy of the value. We are copying the value here. Okay, so actually there is another distinction here. We call it giving another value. Give another value. We give an intersensor's mana. We set it equal to 99. Okay, so in this place, this mana, we just print this mana again. Okay, so this is a kind of post-attached instance. That is, one way is when we bind two additional things, pass them over, and this makes it very convenient. Then another way is to read this UObject, reading its own context. Let's test it for everyone first, then explain it in detail. Why this situation occurs. You might have a question. I have two parameters here. I could just declare this as 3 promises and be done. Of course, you can do that, but why wasn't it done that way? Because it might not be written by the same person. You only have the permission for location actor. You don't have permission for single dedicated actor. This single dedicated actor might be written by you, might be written by the engine. It is already fixed. The delegates function signature is like this, but when you use it, you want to update the health value when printing the location as well as the goal and mana values. So what do? I provide two ways here. One is binding, and the other is for you to read your own object in such a context. This method is used extremely frequently, and it belongs to a relatively hidden, deeper kind of knowledge. In other words, if I don't tell you about it, you might not know. So here, okay, let's not drag it out. Obviously, earlier, should we erase it all? Hold on. Here we still need to write this. Let's write a test entry point. Okay, let's write it here. Here we actually don't care about it anymore. We'll just let it execute, because its execution result is actually the same as here. Note that we need to switch our proxy. At its upper layer, it is imperceptible. That is, this layer is equivalent to the framework layer. So our framework, our Delegator, it is very powerful. It can obtain the three-dimensional coordinates of a specified object. But after obtaining the coordinates, what does this object want to do? That is, you tell me to execute this task. I have finished executing it. Can I also deactivate the point myself? Of course, yes. Then when I lose activation, I need the context data. Then you can capture the current context data in this way. Let me take a look. It should be here. This part is a bit difficult to understand. It's quite troublesome because it involves something unique to Unreal. Instructions. Let's press 3. you will find that here, this health is 100, money is dead, this amount is 99. That is to say, I am now notifying all the location actors in the scene. All location actors, print your positions. Then location actor 1. Okay, I am a warrior. I need to output. My current health value is 100. Then location 2. Okay, I am a mage. You know the position I printed. I still have mana now. Then I am going to deal damage. Then there might be a merchant. He now needs to tally the gold value. But actually, this involves an extended usage like this. So our overall framework has been demonstrated to everyone. Also explained to everyone why this payload is so important. This is value capture. What it captures. What it captures here is this value. Of course, you can also pass some pointers or references, etc. But you need to pay attention to one issue. That is, once you pass references or pointers, if you involve asynchrony or cross-threading, you must observe the lifecycle of this reference or this pointer. Alright, the first part of our first single wave, the most core knowledge has been covered for half an hour. Also explained it to everyone in great detail. Then let's talk about it for the rest of the time. Next, we can talk about its other methods. We'll stop here. Thank you, everyone.